Hey folks, today we are talking about evaluating trig functions. We're talking about what does it mean to evaluate sine of pi over 6. So let's review. Well, we already know how to count around the unit circle to pi over 6. We should already know how to draw a little picture of that. Okay, so let's start off there. So I have my unit circle. Pi over 6, that's the same as 180 divided by 6. 180 divided by 6 is 30. So we're counting off 130. So 130 would take me here. And then we would draw 1 to the origin and 1 to the x-axis to complete our triangle. Now that triangle is too small to work with, so we're going to take that triangle and we're going to expand it and make it bigger so that we can actually fill in some side lengths here. I'm going to take that. Okay, now, as I draw this, I should have a right angle, and I should have a reference angle. So what did we count by to get to this spot? We counted by 30s, so here's my reference angle. Now, when we're talking about sine, we have to go back to our SOHCAHTOA days. So if you remember SOHCAHTOA, that's talking about the trig functions, and the trig functions are really just ratios of sides of triangles. So sine, cosine, tangent, that SOHCAHTOA that we talked about. Well, let's do that first. Let's go to our unit circle and we'll add SOHCAHTOA to our sheet. So we have the trig functions. So the trig functions, there are three main trig functions. They are sine, cosine, and tangent. Sine of theta is equal to opposite over hypotenuse. Cosine of theta is equal to adjacent over hypotenuse. And tangent of theta is equal to opposite over adjacent. So what do I mean by opposite and adjacent and hypotenuse? So let's do a quick sketch of I'm going to grab two random right triangles. All right, so I'll start with this right triangle. This right triangle has two angles. Now we have to pick one to be our reference angle. So I'm going to choose that angle to be theta. And then we can label the sides from here. The side, if you go from the reference angle and you go opposite, that's the opposite side. Then if you go to the 90-degree angle and you go opposite, that's what we call the hypotenuse. And then the third side length that you're going to talk about is called the adjacent side. And to me, when I was a kid, I never worried what adjacent meant. I just knew how to find opposite and hypotenuse, and I knew the other one had to be adjacent. But adjacent means next to. To be adjacent to be something is next to it. So the adjacent side is the side that's next to the angle. Now you have two sides that are next to the angle, but one of them is already designated as hypotenuse, so the other one is adjacent. Now let's say I take another right triangle. Right angle. And reference angle, but this time, now all of our reference angles will always be coming from the origin, so it's going to always be this angle. But I just want to point out how opposite and adjacent works depending on where you're looking from. So this time I'm going to choose this to be the angle that I'm working from, my reference angle. I'm going to use that as reference. So the side opposite, now this would be opposite because I go from the angle and go opposite. You'll hit the opposite side. Go from the 90, you'll hit the hypotenuse side. And then that leaves this side to be adjacent. So when I do a trig function, I'm comparing two sides of those triangles as a ratio. So if I want to do the sine trig function, I would do opposite over hypotenuse. I would divide the length of these two sides of that triangle. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Now we have a saying for this that helps us remember, and this is what we would call SOHCAHTOA. SOHCAHTOA. SOHCAHTOA, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Now, we have two different ways that we can look at the trig functions, though. We have the trig functions, and then we have these other ones that are called the reciprocal trig functions. Now, the reciprocal trig functions are the trig functions reciprocal. So the reciprocal of sine is this thing called cosecant. Cosecant, instead of being opposite over hypotenuse, is hypotenuse over opposite. Cosine's reciprocal is this thing called secant. Secant, instead of being adjacent over hypotenuse, is hypotenuse over adjacent. And then tangent has a reciprocal called cotangent, which would then be adjacent over opposite. So I just went and took these trig functions and I reciprocaled them to get the reciprocal trig functions. This mnemonic is not quite as easy to remember. This would be CHOSHACAO. Choshakao. I don't know. Is that easy to remember? We got SOHCAHTOA and Choshakao. All right. So that's what I'm talking about when I'm talking about trig functions. I'm talking about opposite over hypotenuse, adjacent over hypotenuse, and so on from there. Now, this is where things start to get interesting in the world of the unit circle. Because what do we know is the radius in the unit circle? The radius is always 1. So when I go to any rotation, let's say I rotated up to 60 degrees, I would draw 1 to the origin, 1 to the x-axis. Well, when I do sine opposite over hypotenuse, how long is my hypotenuse? Because this is a radius of 1, when I rotate that radius, no matter where I rotate in the unit circle, my hypotenuse will always be 1. So it turns out in the unit circle, now this doesn't work outside of the unit circle, but in the unit circle, sine of theta is the same as y. Sine and y are the same thing. Because look, let me do it again. Here's a triangle. This is the 45-degree triangle. If I did sine, I would do opposite over hypotenuse. Well, the hypotenuse has a length of 1, so whatever the height is in this direction, it's going to be this number divided by 1, and whatever this is the y direction. See how it's going up and down? Just like the y goes up and down. So using that same argument, if I wanted, here's my 45 again, if I wanted to do cosine, cosine is adjacent over hypotenuse. Adjacent is this side divided by the hypotenuse, but the hypotenuse is how big in the unit circle? Is 1. So it turns out in the unit circle, cosine is the same as x. So opposite and y are basically the same thing in the unit circle, and adjacent and x are basically the same thing. So then what's tangent? Tangent is opposite over adjacent. Well, we just said opposite was the same as sine. Over, we said adjacent was the same as cosine. So there's two ways that I can think of tangent. It's sine over cosine, or it's y divided by x. All right, so now we have to try to make a connection between the actual rotations around the unit circle in radians or degrees, and then the side lengths of these things that are called the special right triangles. So let's see. I'm going to have to squeeze. I guess I'm going to have to put some triangles over here and some notes over here, which I was hoping. I wish I would have written that down there. Darn it. I'll have to do that next year. Okay, so what's the relationship between... I can't fix it. Okay, so let's make a little chart. And our little chart is going to say degrees degree, radian, sine of theta. In other words, the opposite. There were three big angles that we worried about. We cared about the 30 degree, we care about the 45 degree, and we care about the 60 degree. Now, what are the radian measures associated with each one of those? 30. How many 30s does it take? You could go look over here, but try to think it through. How many 30s does it take to make up 180? You would need 6 30s to make up 180. So this is the same as 180 divided by 6, pi over 6. How many 45s would you need to make 180? 45 and 45 make 90. 90 and 45 make 135, plus another 90 makes 180. So this is the same as pi. I need 4 of those to make 180. How many 60s do you need to make 180? Pi over 3. Now, what are the side lengths opposite these angles or these radian measures? Well, here's the first thing. They're all divided by 2. So this is over 2. This is over 2. This is over 2. And what's kind of cool is they go in order. They go 1, 2, 3. 1, 2, 3. But they're all square rooted. Now, I don't have to write the square root here because what's the square root of 1 is 1. What's the square root of 2? I don't know. Some messy decimal. What's the square root of 3? I don't know. Some other messy decimal. Now, look, this is yet again, I think this is the cool part of how the unit circle kind of all fits together. It makes sense that 1/2 is across from the 30, and root 2 is across from the 45, and root 3 is across from the 60. Now, let's first compare these three numbers. 1/2 square root 2 over 2. Dang it. 1/2 square root 2 over 2 square root 3 over 2. So notice, 1/2 is actually the smallest of those. When I was a kid, I saw this didn't have a root, and so my instincts made me feel like this was the biggest of the group because these were getting square rooted, and I didn't really understand what those numbers were. But 1 really is a square root. It's the square root of 1. We just don't have to write it. So it makes sense that the smallest angle would have the smallest opposite side, because if I took an angle and I open it up, the bigger the angle, look at how much farther apart the end of my fingers are getting. So here's a small angle, very close. Bigger angle is farther apart. So these are the side lengths of our triangles that are opposite depending on what our reference angle is. Now let's go over here. Like I said, I wish I would have had room. I wish I would have been smarter and drew it up here so I could draw the triangles over here. But c'est la vie, as they say. We're stuck with it. So now I'm going to draw 3 different triangles. I'm going to draw the 30 triangle, the 45 triangle, and the 60 triangle. So let's start with the 30 triangle. So this is 30 degrees. Okay, how long is the side? Zoom out, sorry. How long is the side opposite 30 degrees? Well, we just learned over here, 30 degrees has a sine value or an opposite side of 1/2. Now, if this is 30 and this is 90, how big is this angle? This is a 60 then. Well, what did we say? How far across is a 60? How long is the side opposite of 60? Square root 3 over 2. So this is one of our special right triangles. Now, I can write it, and if it helps you understand it, feel free to write it up here. How long is this hypotenuse? 1, because that's the radius in the unit circle. That's what we call our 30-degree special right triangle. Now let's make another one. The next one is called the 45-degree special right triangle. This is 45 degrees. Okay, how long is the side opposite 45 degrees? So 45 degrees, I always call this the mama bear. This is the one that's just right. This is baby bear. This is mama bear, and this is papa bear, smallest, medium, biggest. So this to me is always the side that's just right. So how long is the side length across from a 45? This is a root 2 over 2. Now, if this is a 45 and this is a 90, then this must also be a root 2 over 2. So sorry, let me try again. If this is a 45 and this is a 90, then this has to be a 45, which means the side opposite is a root 2 over 2. And the hypotenuse is in the unit circle, so that's a hypotenuse of 1. And then our last special right triangle, I keep calling these now, the third special right triangle is the same as the first special right triangle. It's just tipped over. Because our important angles in the first quadrant are 30, 45, and 60. This is the 30. This is the 45. Well, this would be the 60. Right angle, reference angle. But like I said, these are really the same triangle. One's just tipped on its side. Because if this is a 60 and that's a 90, this is a 30. If this is a 30 and that's a 90, that's a 60. So now I want to think about it from the 60 perspective. The side opposite would be square root 3 over 2. If that's 60, then that means that has to be 30. So this would be 1/2. Kind of squeezing it in here. Don't get those two things confused. And then we have a hypotenuse, again, of 1. Those are called the special right triangles. So now we can take these special right triangles and we can tie them into what we did earlier today by drawing a triangle. So now I've got my triangle. I know my reference angle is 30. I can go to my either the special right triangles, or I can go to my little chart here that has the relationship between angles, radians, degrees, radians, and sines. Either way, but I'm going to fill in now the sides. So here's my 30. What side length is opposite of 30 is 1/2. If that's a 30, then this is a 60. What side length is opposite of 60? Square root 3 over 2. Now, finally, after drawing all of that, we're finally going to apply the sine part of this. Hypotenuse is 1. If I go back, what do we know about sine? There's two ways to think about sine. Sine is opposite over hypotenuse, or essentially sine is the same as y. And you're going to see why really now that makes sense here. Because when I do opposite over hypotenuse, opposite hypotenuse, opposite over hypotenuse is going to be 1/2 divided by 1. And what's 1/2 divided by 1? Just ends up being 1/2. So what's the sine of pi over 6? The answer would be 1/2. All right, let's try another one. Let's see how we're doing here. So next up is cosine of pi over 3. So first of all, I'm going to try to sketch pi over 3. I go to my unit circle. I sketch a unit circle, sorry. If you need your unit circle, you can look back at it. I would rather have you think it through. Pi is the same as 180. 180 divided by 3 is 60. So we're going one gap of 60. So there's my tick mark. 1 to the origin, 1 to the x-axis. Now that triangle is too small to see, so I'm going to take it and I'm going to blow it up. So now it looks something like this. Right angle and reference angle is what we counted by. We counted by 60s. So my reference angle is a 60. Now I'm going to use my little chart, or I'm going to use my special right triangles to fill in the side lengths. 60 is the biggest one. That's Papa Bear. That's square root of 3. 60 goes with a 30. Now, if you want to write 30 up there, you can. I just think about it. That's a 30. 30 is Baby Bear, so that goes with the 1. And then the hypotenuse is always 1, and I'm going to stop writing the hypotenuse after this. So what do we know about cosine? Cosine is adjacent over hypotenuse. So 1/2 over 1 is 1/2 again. And you're going to see that you're going to see answers repeat over and over and over again, because the special right triangles, we just keep using those same special right triangles. Okay, cosine of 3 pi over 4. So let's first figure out where is 3 pi over 4. I'm going to think about this in terms of 180 divided by 4. That's 45. So I'm counting off 3 45s. 1, 2, 3. 1 to the origin, 1 to the x-axis. That gives me the way that my triangle should look. Now I'm going to fill in right angle and reference angle. Okay, 45, that's the one right in the middle, 30, 45, and 60. So this is going to be mama bear, square root 2 over 2. This is also going to be a 45. They're both going to be 45, so this is also going to be mama bear, square root 2 over 2. Now, cosine is the x side, or the adjacent side, divided by the hypotenuse. But in this case, if you just write square root 2 over 2, you're incorrect. It's not a -1, it's a -2. It's a big idea. You are in the unit circle. So if you move this way on the x, you're positive. If you move this way on the y, you are positive. But if you move this way on the x, you are negative. Or if you move this way on the y, you are negative. And if you look at our picture again, this is 0, 0. We went backwards on the x, so that must be negative. And then we went positive on the y, we went upward, so that's going to stay positive. So don't forget your negatives. So I'm going to go back to my unit circle, and I'm going to write that at the bottom. Don't forget your negatives. And what I mean by that is don't forget that direction. I didn't, sorry, you didn't see it. Don't forget your negatives. That what I'm trying to say there is direction matters. You have to make sure that you know which direction you're going. Okay, so let's try sine of 5 pi over 4. Actually, why don't you try it? Pause and try this one on your own. All right, let's see how you did. So I'm counting by pi over 4 is 45. I'm counting 5 45s. 1, 2, 3, 4, 5. 1 to the origin, 1 to the x-axis. That triangle is too small to work with, so I'm going to expand it. Right angle. Reference angle is always the one coming out of the origin. So you always start from the middle of the coordinate plane. We counted by 45, so my reference angle is also a 45. 45 is mama bear, so that's root 2 over 2. Root 2 over 2. Any negatives? Yes. Here's 0, 0. You went backwards, negative. You went down, negative. Both of those are negative. So make sure that you pick the right one, because in this case, you could write either one of them, you get the same answer. Sine is the same as the y direction, or the opposite side. So my answer would be negative root 2 over 2. Pause again. Give it a try. Okay, 11 pi over 6. I'm counting by 30s. I'm counting 11 30s. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that means that my triangle then is going to be down here. Right angle, reference angle is a 30. Opposite of 30 is a 1/2. 30's friend is 60. Opposite of 60 is square root 3 over 2. Any negatives? Yes. This is 0, 0. So we went positive on the x, but then we went negative on the y. Okay, we want to select cosine. Cosine is the adjacent side, or the x side. So that would be square root 3 over 2. All right, now we get into ones that take a little bit of algebra work to clean up. So we're taking a look at, tangent now. So that means we have to take two sides into account, because in these other ones, we didn't really care about the hypotenuse, because the hypotenuse was always 1. So when you divided by the hypotenuse, it wasn't any big deal. In tangent, not quite so easy. So we're going to count around to 7 pi over 4. So I'm counting by 45s. 1, 2, 3, 4, 5, 6, 7. Right angle, or sorry, 1 to the x, 1 to the origin. Take that and blow it up. So this is 45. Right angle, reference angle. 45 is mama bear, so that's root 2 over 2, but it goes downward, so that's negative. This is a 45, so this is root 2 over 2, but it's positive because it goes forward. Now, what do we know about tangent? Tangent is opposite over adjacent. Tangent is the y side over the x side. So for us, that would be negative root 2 over 2 over root 2 over 2. Now, nobody in the world can divide fractions. So what we do instead is we multiply by the reciprocal. That means I turn this from a division problem into a multiply problem, which is legal as long as I reciprocal the second piece. Now, look what happens here. You've got a 2 on the top and a 2 on the bottom. Those are going to cancel. A root 2 on the top and a root 2 on the bottom. Those are going to cancel. So everything's going to cancel out. We're going to be left with a 1 with a negative, so negative 1. So tangent is negative 1 in that case. All right, let's keep going. Let's try to let's have you start off, pause, and at least get to the spot where the triangle's drawn here. Okay, so 2 pi over 3. That's 2 60s. Blow it up. Right angle, reference angle is 60 degrees, which means this is root 3 over 2, which means this is 1/2. This went backwards, so that's negative. That went up, so that's positive. Okay, we're doing tangent again. Tangent is opposite over adjacent. It's y over x, however you want to think about it. So we're going to take the y side divided by the x side. So that's going to be square root 3 over 2 divided by negative 1/2. Now, like I just said, nobody in the world can divide fractions. So instead, we do this move called flip and multiply. So I'm going to multiply by negative 2 over 1. Now, notice what happens here. 2 divided by 2 is going to cancel out. If you want to clean it up, you could write it out, and you'd get negative 2 root 3 over 2, but those 2's are going to cancel. So I'm going to cancel them right away. So root 3 times negative is negative root 3 over 1. Well, what's negative root 3 over 1? It's just negative root 3. And then the last one we want to look at is where the root on the bottom doesn't clean up. So tangent is 7 pi over 6. I'm going to encourage you to pause and try to draw the triangle here. Counting by pi over 6, which is 30s. I'm counting 7 of them. 1, 2, 3, 4, 5, 6, 7. Now I'm going to take that triangle. I'm going to expand it. Right angle. Reference angle is 30 degrees. So across from a 30 is a 1/2. Adjacent to a 30 is a square root 3 over 2. Any negatives? Yeah, both. This goes backwards, negative, and downwards, negative. Now, tangent is opposite or y over adjacent or x. So opposite over adjacent, y over x. Either way, it's going to get us to negative 1/2 over negative square root 3 over 2. No one in the world can divide fractions. So what we do instead is multiply by the reciprocal. So this is now, I'm going to take this negative. When I flip it, I'm always going to put my negatives on the top. That's always an easy fix, and you're not supposed to have negatives on the bottom. So to me, that's an easy fix. So what we get now, negative times a negative is a positive. Those 2's, I got a 2 on the top and a 2 on the bottom of a multiply problem, which means those are going to cancel. So I'm going to be left with a 1 and then a root 3 on the bottom. Now you might remember this from our earlier notes, but you're not allowed to have a root on the bottom. So I need to now rationalize, it's called, rationalize by multiplying the top and the bottom by root 3. So what's 1 times root 3? Root 3. Over, now this is where it gets interesting. What's root 3 times root 3? Well, because they're both underneath roots, we can multiply them together. So 3 times 3 is 9, but what's the root of 9? It turns it back into a 3. So a little shortcut here, root 3 times root 3 is 3. Root 7 times root 7 is 7, because root 7 times root 7 is root 49, but root 49 is just 7. So it's kind of like, it's not even kind of like, you're squaring these, because a root 3 times a root 3, that's the same as root 3 squared, and so the root and the squared cancel out, and you're left with the number that's underneath. Now that only works when they're the same number. If they're not the same number, you're in a different boat. All right, now we've got secant coming up. Well, look, secant, cosecant, and cotangent are just reciprocals of the regular trig functions. So you're going to take your regular trig function and you're just going to flip it over. You're going to reciprocal it. So let me show you what I'm talking about here. So first of all, I'm going to figure out where's 5 pi over 6. So let's figure that out first. Pi over 6 is 30, 5 30s. 1, 2, 3, 4, 5. Take that, expand it. Right angle, reference angle. 30, baby bear. 30 is matched up with 60, which is Papa Bear. So 1/2 and square root 3. Any negatives? We went backwards, but up. So only one negative there. All right, secant. The way I usually do this is I take whatever this trig function is and I reciprocal it on the paper. So in other words, what's the reciprocal of secant? Hopefully you said, dang it, I never can pick a good color. Yeah, we'll go with it. Secant's the reciprocal of cosine. So which one of these is cosine? Cosine and x are the same thing or adjacent, depending on how you want to think about it. So this is what the cosine is. Now we don't want cosine, we want secant, which is the reciprocal of this. So I'm going to take this thing and I'm going to flip it over. So when I reciprocal this, I'm going to always push the negative to the top. Now what's wrong with this is we have a root on the bottom, so let's clean up that root on the bottom. If I times the bottom by root 3, I got to times the top by root 3. And then we end up with negative 2 root 3 over root 3 times root 3 ends up being 3. Okay, a lot of stuff there. This is one whole page of the test. This to me is 25% of what I expect out of this unit. So this is a big, big idea. So now let's take all these ideas and we'll apply it to the 6 trig functions at a given angle. So now we're going to use one triangle. We're going to draw one triangle. We're going to use that to answer all 6 of the trig problems. So let's first figure out where 4 pi over 3 is. Pi over 3 is 60. I'm counting 4. 1, 2, 3, 4. Right angle, reference angle. Right angle, reference angle. Okay, what side length do we know? 60 is Papa Bear, so that's square root 3 over 2, and it's pointed downward, so that's negative. 60 is matched with 30, so that's Baby Bear, but it's pointed negative, so that's negative 1/2. And we're supposed to find all the trig functions, so that's sine of theta, cosine of theta, tangent of theta, and then cosecant of theta, secant of theta, cotangent of theta. So I usually find these by finding these first. So sine and y, or sine and opposite, are the same thing. So this is going to be negative square root 3 over 2. Cosine, adjacent, or x, so negative 1/2. Tangent, tangent takes a little bit of work. So tangent is sine over cosine. So that's negative square root 3 over 2 over negative 1/2. Nobody in the world can divide fractions, so we flip and multiply instead. So negative times a negative is a positive. Those two cancel, and then we get just root 3. Okay, let's move on to cosecant. Cosecant is the reciprocal of negative root 3 over 2. So I'm going to reciprocal that, so that's negative 2 over root 3. We don't like the root on the bottom, so we're now going to clean that up with a root 3 over root 3. So we would get negative 2 root 3 over 3. Negative 1/2 reciprocaled is negative 2. Square root of 3 reciprocaled, so I'm going to make that into a fraction in my head. Square root 3 over 1, and then I'm going to reciprocal that over. So that would become 1 over square root 3. And then I'm going to times by root 3 over root 3. So I get root 3 over root 3 times root 3 is root 9, or just 3. And I didn't talk about this yet in all the ones up above, so let's talk about what happens when you hit one of the corner points. What happens when you do your angle and you end up at a spot where we couldn't draw a triangle. You might remember from section 6.1's homework, but let's go over it together. So we would get something like this. So where's pi? Pi is over here. The problem with that, we can't draw a triangle there, but we can identify this as the point. This is the point negative 1, 0. So I can still do all my trig stuff because sine, let me get them, I'm going to write them out first. Okay, what do we know about sine? Sine is opposite over hypotenuse, but when we don't have a triangle, sine and y are the same thing. Sine and y are the same thing. So which one of these is y? 0. So sine and 0, let's go with a green. Sine and 0 must be the same. Cosine is x. X in this case is negative 1, so cosine is x. What do we know about tangent? Tangent is sine over cosine. 0 divided by negative 1. 0 divided by negative 1, that's okay, because the 0 is on the top, so 0 divided by anything ends up being 0. Now, we're going to take these and we're going to find their reciprocals. So the reciprocal of 0. Okay, 0, if I made that into a fraction, it would be 0 over 1. When I reciprocal 0 over 1, I would get 1 over 0. 1 over 0 is not okay. That's undefined. So in this class, or not even this class, you can always remember the reciprocal of 0 is undefined. The reciprocal of undefined is 0. These are reciprocals. So either you have nothing or everything. Everything would be something we don't know the answer of. Infinity is not a number. So what's the reciprocal of 0? Undefined again. 1 and negative 1 are also interesting things to reciprocal. They're the only numbers whose reciprocal is themselves. I mean, think about the number 1. Make it a fraction, 1 over 1. Reciprocal that, 1 over 1. What's 1 divided by 1? 1. Same thing with negative 1. Negative 1 over 1. Reciprocal, 1 over negative 1. Well, 1 over negative 1 is still negative 1. So the reciprocal of 1 is 1. The reciprocal of negative 1 is negative 1. All right, big lesson here, big one. So make sure you attack that homework. This is not one that you want to kind of blow through without thinking it through. Good luck.